and now someone else is going to use it to validate announcements. And that is how it works. You have the 5 trust anchors. Those are the 5 regional internet registries. You need a validator, so you could even, for example, just download it on your laptop, but it's obviously you're going to have a machine in your network, a validator, and the validator will get all the information, all the certificates and the ROAs, and then create a validated cache. So it will check using this RPKI, chain of trust, it will check the validity of all the ROAs, and only the valid ROAs it will put in the cache, and after that, that is then communicated, I don't know, in whatever periods with the router, and then so the router doesn't have to do the validation, it doesn't slow it down, and then the router can compare it with the announcement to see if they are valid or not. So here you can see on the left-hand side, you have you as a user, you have the validated cache that you created with your validator, and then there you have your router, and there you have the BGP announcements, and then you can compare the two and then make whatever decision. But as I said, the decision is yours. You then can configure your router and say, if valid, then do this, or don't do this, or whatever you want to do, yeah? So this is now the full system. At the top, you have the ROAs in the repository, which is on the RIPE-NCC's platform. Then you, the validating party, has the validator software. In the validator will create the validated cache, only those ROAs that are valid, that says which prefix is announced by which AS and which are valid. It has checked it. And after that, you can see the protocol is RPKI, RTR. That's the protocol between the validator and your router. And most platforms, most routers actually have this already built in, so they understand this. And then the routers can make whichever decision based on that. Okay, a little bit of statistics. So you can see here for the 5 regions that, of course, RIPE-NCC has the most certificates. So a certificate, you only have one certificate, and in your certificate you have all your different prefixes together, IPv4, IPv6, and then you create ROA for each prefix separately, yeah? So these are the number of certificates, and we have just passed actually 10,000 a few days ago. So you have, in total, if you add this all up, you can see there are 30,000 certificates. And you can see the coverage, so you can see in which regions in the world, how many, what percentage of the announcements actually have ROAs, has actually created ROAs for which announcements. And you can see, of course, for example, in Europe it's quite high, it's between 0 and 100%. And then, here you have the accuracy. So that means from the ROAs that are created, what percentage actually completely reflects what is actually being announced in real life. That's the accuracy. And you can see that again between 0 and 100%. And here you have some statistics for the region. So you can see that 66% of the addresses actually in Serbia already have ROAs. So based on RPKI, 66% have created ROAs for their address ranges in the Republic of Serbia. And then you can see all the other countries there, and you can see the accuracies. From these ROAs that they created, what percentage is accurate? And you can see the accuracy is really high. So there aren't a lot of mistakes, let's say, let's put it that way, or malicious, yeah. But that, hopefully, that you can't create. Okay. Right. So what should you do? Create your ROAs in the LIR portal. Perhaps what I should tell you just very briefly, what does it mean if you want to do this? This is very simple. If you are an LIR, you go into your LIR portal, and you can just click a button, I want a certificate. So it's your choice. If you want a certificate, you get a certificate, and then you can create ROAS. The interface is very easy, because the only thing you will see all your announcements. We have that from root collectors, so we collect it from the internet. You see your actual announcements, not what's in the database, but the real life. And based on that, you can, for each of your announcements, you can create a ROA, yeah? And it's just a click of a mouse, so you don't have to worry about you have logged in any kind of authentication keys. That's done automatically. And so you create your ROAS in the LIR portal. The important thing is to pay the main problem can be the maximum length. So if you create a ROA for your announcement and you just say default maximum length and your announcement, your prefix is a /21, then if you want to announce a /22, that will be invalid. If you know you want to do it, then you have to change the maximum length when you create the ROA or later and change it from default to /22 or /23 or /24. Also, as I said, if part of your allocation belongs to your customer and they are announcing it from a different AS, then you can create separate ROAs for the rest of your allocation from your AS, and you can create a separate ROA for your customer with a different AS, yeah? So you can do whatever you need to do. So create your ROAs. Make sure you get the maximum length attribute correctly. That's the first part. So now you have done so that others can use RPKI to validate your announcements. Your job is finished here. I mean, okay, you check it occasionally if it's up to date and all that. After that, you can also use RPKI to check the validity of what other people announce. And that you start by downloading the validator. You can also check the validated status. And if, for example, your grandfather is announcing a prefix and it's not valid, but you like your grandfather, you can update it manually. So you can make exceptions to it. So you have that freedom as well to add and remove ROAs from the validated cache. And after that, set up monitoring, and that's it. Now, the question is, what happens if you say, okay, I do RPKI, and I did it, and then I also do the validation, and then so I integrate it in my routing. So basically what I do is my router and the validator, they are going to check if an announced prefix is valid. And you say, I'm going to reject anything that's invalid. You're not going to reject anything that's unknown. Unknown just means that they didn't do RPKI, they didn't create ROAs. So that's not a problem. But if you see from RPKI that there's a ROA that says this prefix can be announced by them and someone else is announcing it, and what happens if your router now, based on this, rejects the prefix? And this is what we found out, what people's experience is, what you see on that slide, what happens. So to summarize it, it's not a big problem. So, for example, someone created a bad ROA by mistake and now you reject it because they made a mistake. How negatively will it impact you because you reject actually something that they wanted valid? So basically you see mostly nothing. That's what AT&T said. 5 customer calls in 6 months to give a feeling, all resolved quickly. Dutch ISP. Customers appreciate that you take security really seriously, so you use RPKI. There are many invalid, but usually it impacts very little traffic, because usually the major players will know what they are doing. So that's the feedback on that. So that's it, really. The question is,